In mathematics, we always need to be careful with notation. So this video, we're going to discuss two types of notations, and then they are fairly closely related, but we do want to make some distinctions between them. The first one notation we call prime notation, and so if we want to talk about the instantaneous rate of change, or how much it's changing at a precise value, instantaneous refers to a precise value or known time or place in space. We denote that quantity by, or if it's a quantity y, we denote the instantaneous rate of change by y prime, and that's how this symbol is read. So in linear models, so remember, linear models was in the last video. This is y is equal to mx plus b. We say that the instantaneous rate of change, well, what is the rate of change in a linear model? It's just m. So we say we can actually identify y prime as m, okay? And then consequently, if we wish, this means that we can rewrite the linear model as y is equal to y prime, the instantaneous, or the rate of change in y, times x plus b. Okay, we can rewrite it if we wish. Okay, now the other type of notation is called delta notation. We saw this when we were talking about slope. Okay, so when we were talking about slope, m, okay, well, this what we said is rise over run, but we also identified it as delta y over delta x. And now it's time to clarify this notation. So delta, it's not a triangle, it's a Greek letter delta, refers to a change, difference, or step in a quantity, and we typically represent it as t sub, if it's for an independent quantity, t sub 2 minus t sub 1. You can do it in the opposite order, doesn't much matter. And then for a dependent quantity where y of t depends on y, or depends on t rather, delta y is defined similarly. Okay, and now we're going to really discuss what the difference between the two is. Okay, so again, prime notation we said looks at an exact time in space, or not necessarily an exact time, but an exact value, how it's changing at a very precise value. Delta notation really is looking at the change over a time period or over a range of values. And so that is conceptually that's the difference between the two. Now, when we get into the nitty gritty with the algebra or analyzing everything, if the time period or if the change in the values is really, really small, then delta notation actually gets really, really close to prime notation. So if it approximates it, meaning that if we have the change or the change in our value to be much less than 1, that's how we read this. So the double less than sign, we can say that the appropriate way to say that is much less than. So if it's much less than 1 or really close to 0, same idea, then we say that the delta notation approximates the prime notation. Okay. And then similarly, but that's real. I mean, this is okay. But now we want to talk about, well, we have independent quantities and we have dependent quantities. How do those change between the two types of notations? So if we look at the dependent quantity first, if the change in the value, we should say the independent value, is really, really small, then the average rate of change in the dependent quantity approximates the instantaneous rate of change in the dependent quantity, meaning that, well, here's our expression for average rate of change. We can express that as delta y over delta t, and this whole thing approximates the instantaneous rate of change when this is true. Okay, so this actually should look fairly familiar. This is just like our slope equation that we wrote before. So delta y over delta x. And so with the average rate of change, it approximates the y value. And in fact, we can do even a little bit better. And then, sorry, and we can rearrange this, multiply by delta t on both sides and get delta y is equal to y prime delta t. Okay, and I want to point one thing out. Remember, if we write this out, write out the definition of what delta y means. This is y2 minus y1 is equal to, well, I should say approximately, is approximately equal to y prime, and then delta t is t2 minus t1. Okay, that should look familiar. Think about the slope intercept or point slope form of a line. Okay, and then lastly, if we're on a line, so if we know that we have a linear model or a linear relationship between two values, we actually get strict equality, meaning that the approximation that we had is actually equal to. Also, at the same time, so we get strict equality, but remember what we set up here. So the average rate of change approximates the instantaneous rate of change. Okay. Down here, when we have strict equality, we say the average rate of change is the instantaneous rate of change. Okay, and so on a line, if you know one, you know the other. Very useful property. Okay, and that's a brief overview on the difference between prime notation and delta notation and how and when we can use both.